Welcome to Spring LIB.
So we know that in a Compton effect, the wavelength of scattered photon minus wavelength of the incident photon or the original photon is equal to lambda c, that is the Compton wavelength, times 1 minus cos phi, where phi is the scattering angle. And lambda c, that's the Compton wavelength, is equal to Planck constant over mass of an electron, rest mass of electron, times speed of light. And this is a constant, and that constant is called the Compton wavelength. Now we are given that lambda dash is equal to lambda plus 1 over 100 times lambda. So this means that lambda dash minus lambda is equal to, so I'm simply substituting this equation, this expression of lambda dash in the above equation of Compton effect. So we have lambda dash minus lambda to be equal to lambda plus 1 over 100 lambda, that's lambda dash, minus lambda, and this is equal to lambda c minus 1 minus cos phi. Sorry, lambda c times 1 minus cos phi. So this is equal to, so lambda and lambda cancel out, and we are left with lambda over 100 to be equal to lambda c times 1 minus cos phi. So now we can solve for cos phi. So cos phi is equal to 1 minus lambda over 100 lambda c. And then substituting the values for lambda and lambda c. So lambda is given to be 0.9 times 10 to the power minus 10 meter, and lambda c, that is equal to h over mc, and this as a whole is a constant, so you can use the value of this Compton wavelength, the constant, directly, or you can use or you can choose to substitute h, m and c over here, and then substitute the values of these and then solve the equation. So I know the value of h over mc, I know the value of Compton wavelength, and that is equal to 2.426 times 10 to the power minus 12 meter. So I'm directly substituting this value along with the value of lambda over here, and this will give me the value for cos phi, and that comes out to be 0.629 degree. So from here we can say that phi will be equal to cosine inverse of this value, and that comes out to be equal to 51.0187 degrees. So that's the scattering angle.